How do you find the probability of an intersection of events? You divide the number of outcomes in the intersection by the number of outcomes in the sample space. The intersection, therefore, represents the favorable outcomes. Let's continue by using the example from the previous video about unions to understand this better. Say you want to find the probability of rolling A, an even number, and B, a number greater than 4. You can think of A and B as two events. The first event, A, consists of the outcomes 2, 4, and 6. The second event, B, consists of the outcomes 5 and 6. In this case, you're looking for the intersection of the two events, namely, all outcomes that are in both event A and event B. A common notation for AND is this symbol, which looks like an upside-down U. This time, you have to find outcomes that are exclusively in both sets. You organize these outcomes into a new set, the intersection. So, you compare the two subsets to find their common outcomes, which represent the intersection. Here, the outcome 6 is the only outcome that is present in both subsets. So the intersection of A and B is 6. To find the probability of the intersection, you count the number of outcomes in the intersection, the favorable ones, which is 1, rolling a 6. Then you count the number of total outcomes in the sample space, which is 6. So the probability is 1 divided by 6, which equals 1/6. Now, be sure to be careful and read the text of the problem closely to figure out what you're being asked to calculate. This is the key to success in probability. It's really important to understand the difference between a union of events and an intersection of events. To know which one to use, you should look for the words OR and. If you're asked to find the probability of A or B, you need to use the union of the two. But if you're asked to find the probability of A and B, you need to find the intersection. To find the probability of the intersection of two events, you divide the number of outcomes in the intersection by the number of outcomes in the sample space. The intersection, therefore, represents the favorable outcomes.